Good morning, class. Welcome back to CIMS 389. Today, we're going to continue to talk about statistics. And the topic for today is a measure of a central tendency. Measures of a central tendency, mean. A measure of central tendency calculated by dividing the sum of the score in a set by the number of scores. So typically the formula given the mean x bar equal sigma xn divided by n, okay? So we have a keyword for this, that means sum, okay? Sum of the total and then divided by how many numbers there, right? So for examples, here's an example. At a ski rental shop, data was collected on the number of the rental on each of the 10 consecutive Saturday. So here we have a data, all right? Here we have data. And what we find, how we find the mean? We added up the total of the number, right? And then what's next? We divide it by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why we divide by 10, right? So what's the mean? Mean actually is a 49.2, okay? So the total add together here, we call like this, we call it, sigma xn. So this is a sigma, this is called a sigma xn. And this is n, all right, divided by n. And that's how the formula works, okay? And next, keep in mind the mean is, the keyword is a sum, all right? The average, the average, okay? We all add together all the number and divided by how many number there. So therefore, we have average. Now, what about median? The median is a measure of central tendency corresponding to the midpoint, so midpoint, in the distribution of a score. And that point value, which is 1/2 of 50% of data score, right? So again, I'm gonna give you the same problem like this. So here is the data we have, here's the data we have. So how we find the median? First of all, we have to sort the data. We sort the data from the least to the greatest number, right? Then we find what's the middle. Oh, middle is right between 44 and 46. So therefore, we take a 44 plus 46 divided by 2. So therefore, 45. So median is located right here, which is 45. All right, median, okay? So here is a median. The next one is a mode. A measure of central tendency corresponding to the most frequently occurring score in the distribution of score. So most, okay, most. So in this data set, what's the most number? And then again, we have to sort the data. Now, once we sort the data, we can find, okay, we got a 250 there, all right? So 50 is the mode because it occurs twice and then the rest of the outcome occur only once, okay? The next is, we're gonna talk about what's the term for low quartile. The low quartile is the first quartile, or say we wanna say Q1 or 25% of the score lie at below Q1, okay? Now upper quartile, the third quartile is the median of the score greater than the median of all score. 3/4, 75% of the of the score lie at the below Q3, okay? So low quartile, up quartile. And then later we're gonna talk about box and Wixel plot, later. And then we're gonna talk about outlier like this, okay? So now, give you examples, Here is example, all right? 5844638, okay? We have this data set, right? But what's the Q1? What's Q1? So basically we have to solve the data like this, from the least number to the greatest number, right? And next, we find the middle number. What's the middle number? Middle number is a 5. This is a median. This is a median we talked about earlier. This is a median, right? And then we also say this is a Q2, okay? Now, what about Q1? Q1 is based on this group of data. So we have 344. 344, we're gonna find out another median. What's the median for this? Which is a 4, right? So that would be Q1, okay? Now what about Q3? Q3, we have another group of data like this, right? So that will be, we will find another median, okay? So find another median of this group. We have a 688, so that'll be 8, right? So Q3 will be 8, okay? Another example. So we have this data set, and then again, we're gonna sort the data from the least number to the greatest number, right? Now next, we're gonna find what's the median, middle number. Middle number is right here, which is the middle number is 5, because 5 plus 6 divided by 2, so 5.5 would be median number, right? So that would be Q2, okay, median. Now, well, low quartile, which is Q1. So here, we're gonna take this group of data, and we find another middle number of this group, which is 3, right? Did you see the middle? This is 3. So that is Q1, low quartile. Now, what about Q3? The other group of this, all right? Find another middle number right here, 7. 7 would be Q3, okay? What are the quartile for the following set of the number? So we're gonna find what's the quartile for this number. So here's the answer. You wanna take a look? We're gonna sort the data like this. So we sort the data like this, right? All right, sort the data. Now we sort the data, we wanna find median, okay? Median is right here, right? So right here, so therefore we have 11 and between 11 and 15. So we take 11 plus 15 divided by 2. So therefore, we will get 13 for this, all right? So Q2 will be 13, all right? Now, next, we want to find Q1, the low quartile. The low quartile right here, right? We want to find another middle number of this group. It's right between 6 and 8. Did you see in the middle? So that'd be 7, right? Now what about Q3? Q3, how we find Q3? Q3 is another group of this. We'll find another middle number of this. So 16 and 17. Now let's take a 16 plus 17 divided by 2. So therefore, we got a 16.5, okay, 16.5. So 16.5 will be Q3, right? Does it make sense to you for Q1, Q2, and Q3? Okay, now another set of data, example, how we find a quartile, all right? So here, again, we're gonna sort the data from the least number to the greatest number, right? And then we want to find middle number right here, right? Which is a 16.5. Okay, we'll find Q3, Q2, okay, Q2. Now we take this group of name number. We can find Q1, right? Find this group of number and find another middle number. Another middle number, the middle number here will be 9, right? Did you see it? Now another group of this group of number, we find a middle number, which is we take a 20 plus 23 divided by 2, so we have 21.5, right? So actually Q1 is 9, Q2 is 16.5, and Q3 is 21.5. All right. Interquartile range. Now, interquartile range is a range, from Q1 and Q3, Q1 and Q3. So the formula to find an interquartile range, we say IQR, QR, interquartile range. We take a Q3 minus Q1, and then we can find this range, okay? This is IQR. All right, so here, what is the interquartile range for the following set of the number? So in this set of data, we, from the least to the greatest, right? And then we find Q1. We'll find Q1 is between 9 and 11. So Q1 is 9, 11, right? It's Q1. And what about Q2? Q2 is between 18 and 20. Okay, go back to here. Q2 right here. And then we find Q3. Q3 is 16 and 17. 16 and Q2. Oh, it's no, Q3 actually is not, is 31 plus 33. Okay, Q3 right here. Okay. So we find the data Q1, Q2, and Q3, right? Now here is what's the quartile range? Interquartile range, we have to find Q3. What's the Q3? Q3 is between this number, so therefore Q1, Q2, Q3. Q3 is 32. Q1 is how many? Q1 is 10, right? Q1 is 10. So therefore, you take a interquartile range IQR, which is equal 32 minus 10, which is equal 22. So right, so that will be the interquartile range for IQR for this problem. Okay. Box-Whisker plot. A box-Whisker plot is a way to display data visually and draw informal conclusions. These plots are visual representation of 5-number summary of the data. The 5 numbers are median, upper, lower, quartile, and least and greatest value, distribution, the center, and the spread, and the overall range, and immediately invariant and evident by looking at the plot. Okay. So here, Box-Whisker plot, we have a 5 summary. Okay, 5. What's the 5? Number 1 is what? Is the least, and then greatest the number, right? Number 1 and number 2. What else? Median. What else? Low quartile and upper quartile, right? So we have a 5 summary. We have 5 numbers. Lowest value, higher value, Q1, Q2, and Q3. Okay, and we can make a box with the plot for this. Here is an example. We have a data set like this. All right. Then how can we make a box with plot? So first of all, again, we're gonna sort the data from the least to the greatest. The least is 3 and greatest is 8, right? All right, so we have a 3 for the least. Greatest is 8, right? Now what about Q1? Q1 is, let's find Q2 first, because if you wanna find Q1, you have to find Q2. Q2 actually is a median, so median is a 5, right? Once we find a 5, then this group of data, we find another median, which is Q1, which is 4, right? So which is 4, right? So what about Q3? Q3 is this one, all right, this group of data. And then we find the middle number, which is 8, right? So therefore, we have a 5 summary. We have a list number, and we have a median number like this, okay? And then we have Q1 like this, right? And then we have Q3 and mixed number, and then we can draw a box like this, you know, and we have a whisker and whisker like this, okay? Let's take a look at another example, okay? This is a set of the data, and then this set of data, and then we can find what's the Q1, all right, Q2 and Q3. So the median number is right here, which is a middle number, which is 5.5. So that'll be Q2, okay, Q2. And then we have least number this, we have greatest number like this, right? And then we have, next we're gonna find Q1, okay, 5.5. So we take this group of number and we find a middle number, which is 3, right? And we take another group of middle number, Q1, and then we find another middle number, which is Q3, right? Okay. So we have a Q1, Q2, Q3, right? Now Q1, which is 3. Q2, 5.5. Q3, which is 7. And then we can make a box like this, all right? And what else we have? We have least number and greatest number. Least number and greatest number, make it a whisker. This is called box whisker plot, okay? Now outlier, an outlier is a value like widely spread from the rest of the group of data. An outlier is any value that is more than 1.5 times the interquartile range above the upper quartile or below the lower quartile. Right. So here is the formula we can find the outlier, okay? If less than, you know, Q1 minus 1.5 times IQR, then that would be the outlier. If we find a number greater than Q3 plus 1.5 times IQR, and not the outlier. Okay, so now here is example. Here is example. Now the example here, you can see, I want to find out is 150 an outlier? Yes or no? Let's find it out, okay? So first of all, again, we have to find Q1, Q2, and Q3, okay? Q2 is a median. And Q1 is a median of this, which is Q1 right here. What about Q3 right here? Okay. So interquartile range, we learned this earlier before. We take a Q3 minus Q1, which is equal 3, right? Okay. Now we take the number, okay? The least number minus 1.5 times 3, 1.5 times 3. So we're gonna find, oh, 87.5. Okay, any number less than 87.5 is outlier. Do we have this number less than this? No. Now what about another, number? We take a 95 plus 1.5 times 3, and we gotta find 99. We find 99.5. Any number greater than 99.5 is outlier. Do we have this number? Yes, because 150 is more than 99.5. So we have outlier. 150 is outlier. Okay. So now here, I'm gonna move on to measure of a spray, which is a standard deviation. Now definition, a measure of the extent to which the score in a distribution deviate from their mean. Okay. So here is a step we will find a standard deviation. Okay. First of all, you just calculate the mean, and then secondly, you will write a table that subtracts the mean from the observed value, square each of the differences. Now, fourth step in the add column, and the next divided by n minus 1, where n is the number of the item in the sample. And this is the variance. To get the standard deviation, we take the square root of the variance. Okay. And what does this mean? And then let me give you an example. We will do this step by step, okay? To find the standard deviation. This is a formula, all right, of standard deviation. Okay, so don't be scared with this formula. We come back this, okay? For example, here is a example, okay? Well, that's finding out standard deviation. The owner of an ABC restaurant is interested in how much people spend at the restaurant. And he examines 10 randomly select recipe of parties of 2 and write down the following data. So this is the data, okay? And how we find a standard deviation for this. Now, first of all, we had to find the mean, right? So we add together of this data, add together and divide it by, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers here. We have 10 numbers here, right? So add together, that's why divided by 10, right? So our mean is actually 49.2, okay? Mean is 49.2. And then to find the standard deviation, here we talked about this before. We calculate the mean. So did we calculate the mean? Yes, we've calculated the mean. All right. And next, we want to write a table, and then subtract the mean from each observed value, and then square each of the differences, and in a column. Okay. And this is what we do. Okay. Take a look. This is the raw data we have. Okay. And then we find the mean. This is the mean, all right? This is the mean, okay? So now we take each individual number minus mean. For example, we take a 44 minus 45 minus mean, which is 49.2, okay? And we got a negative 5.2, okay? And then next, we take a 50 minus 49.2, and we got a 0.8, something like this. And we complete this table, okay? We completed this one. And looks, here we all have a plus and minus, right? And the mathematicians say, why don't we just, square, and then we take a square root back. So we don't have any positive and negative number, right? So that's why we have another column of this. This is called a square, okay? So we take this number, individual number, 44, minus the mean, okay? And then we take a square, all right? We take a square. Same as here, we take an individual number, minus mean, and we take a square, okay? Something like this. And therefore, we added out the total of the square, which is how many? Which is 2,600.4, right? And then divided by what? Divided by n minus 1, n minus 1. So we divided by n minus 1. So therefore, we got a 289, right? 289. And this is called a variance. Right? The variance is 289, right? 289. So now we want to find a standard deviation. We take a square root of 289, which is a standard deviation, right? So which is 17, right? So basically, you will find a variance. Square root of variance is a standard deviation. This is how we find the standard deviation. Now, standard deviation will help us to find how, will help us to find out the number, how far away from the mean. How far is it away from the mean, right? For example, this is an IQ test, right? But we don't know, how good the people we see. So, the standard deviation for this is 15. And that will help us to see how far away from the mean, right? So that is 1 standard deviation, 2 standard deviation, 3 standard deviation, right? If we determine the standard deviation, and we can see this is a 1 standard deviation away from the mean, or 2 standard deviation away from the mean. This is what's the purpose we're looking for the data, okay? We can see how spread is, right? Let's say somebody got a 115, right? How good we are, we don't know, but we have standard deviation can measure how good these people got this score. Same as if somebody got a 130, we can use the standard deviation to measure how far away from the mean. Same as 85, right? So this is how we find the standard deviation, okay? Now, if you have any questions for this video or for this lesson, please let me know and I'll be happy to help you, okay? Thanks for watching and you have a great day. Bye-bye.